Hey, good morning, mathematicians. Let's go ahead and get started on today's lesson, which is going to cover operations with functions again, and we're going to talk about one of the last operations, which is division. It's not going to involve a ton of division, actually, but we are going to set it up as a division problem, but really it's going to be just kind of in ratio form. And more importantly, we're really going to get down to, whenever we have especially rational expressions, rational expressions are fractions, we are going to be really interested in what is the domain, because we definitely have to be careful about what are the values that x, or whatever the f of x is. We want to know what values of x cannot work, because if you have a fraction, what number do you not want in the denominator? You don't want a 0. So that's going to be important. Now this is going to be a relatively short lesson. It's not going to cover it's not going to be very dense. It's not going to cover a ton of topics. But what we have here is we have our function notation for a rational function. Now we know that it represents division because we know that fractions represent division. So what we have here is we have the f function of x. The f function of x is x squared minus 1. And then we have the g function of x, which is x plus 5. And now all we have to do for this, essentially, is just kind of write it all out. So I'm going to take the f function and put it in the numerator, which is x squared minus 1. And I'm going to take the g function and put that in the denominator, which is x plus 5. Now you might notice, actually, that the top is a difference of two squares, which can be factored, and that in turn might affect the denominator if you can perhaps cancel stuff out. But we're not there yet in terms of evaluating and working out rational expressions. So what we're going to do really for this problem in particular is we're going to focus on this denominator, because we need to figure out the domain. Okay, the domain is something we can't just say, well, that's all there is to it. You can't just do that. So what we have to do is we have to be very careful about, especially the denominator, what are the constraints? Remember, the constraints of, especially when we're talking about a fraction, the constraints are going to make whatever that denominator is equal to 0. So if we have a 0 in the denominator, then we have something that's considered undefined, and we don't want to have that. All right, so what do you want to do to figure out the constraints? Well, all you have to do is just solve the denominator, is to set the denominator equal to 0, and just solve it for x, and whatever you get for x, that is going to be your constraint. So this is not, like I said, this is not a very complicated equation, but you get x equals -5. Now we're not saying that x, according to this function, we're not saying x equals -5. -5 is one of our constraints. That's one of the values that x cannot be. I know it seems kind of weird, like, why did we solve this? Why did we need to figure out what x was if that's what x isn't? Well, that's part of the process of figuring out domain. So the domain is going to be all reals. Use the symbol there for all reals, except, and we're going to write down our exception here, except when what? X equals -5. So it's every number is possible for what the x could be, except there's one number that doesn't quite fit, and that's the x equals -5. Okay, moving on to example 2 here, we've got, again, it's kind of a similar format here. We've got the f function, which is -3x minus 1. We've got the g function, which is -2x squared minus 3. And then you have your notation here, which is your g function divided by your f function. And just like on the last one, we're just going to basically set it up. We're going to put our g function on top, so -2x squared minus 3. And we're going to put our f function at the bottom. In terms of just setting it up as a function, we're done. All right, but we're not finished with it, because we need to figure out the domain. What is the domain going to be? And the domain is going to depend on that denominator. The denominator is going to tell us what our constraint is going to be. So we're going to take that denominator, -3x minus 1, and what are we going to set it equal to? we're going to set it equal to 0. That's right. So now we're just going to go ahead and just solve this. This is a really simple two-step equation. So you're going to add 1 to both sides. Those are additive inverse right there. And then I'm going to rewrite it. I've got negative 3x equals 1. And now it's down to one more step left. We're going to divide both sides by negative 3. Those cancel out right there. X equals negative 1/3. I know there's a negative there, but I always kind of tell you guys to put that negative there, or just put it in line with the fraction. But it's kind of a weird, awkward spot to put it in that denominator. So just keep it either in the numerator or right in line with that fraction bar. So remember, we did not just figure out what x is. What we just figured out was the domain. So the domain is all reals except one thing. There's except when x equals negative 1/3. All right, so everything would work fine, but if we put negative 1/3 in there, then we're asking for trouble for that problem. We're asking for trouble. We got negative 3. If I do negative 3 times negative 1/3, and if I take away 1 from that, well, negative 3 times negative 1/3, that all cancels out. I get just 1, and then 1 minus 1 is equal to 0. So that is, yeah, like I said, that's asking for trouble. You don't want to have a 0 in that denominator. All right, so there's two things. Let me just kind of make sure this is clear. There's two things that were kind of important that we did here. One thing is that we kind of wrote it in the right format. That's all you had to do. If there's anything that you can do to that, I mean, there is something you could do. Perhaps you can get rid of all those negatives that are part of the leading coefficients in the top and the bottom. But really, that's not a thing right now, so let's just not worry about that. And the other thing that's kind of important is we figured out the domain. Okay? So the domain is all reals except when x is equal to negative 1/3. Moving on to number 3 here, example 3. We've got the f function on top and we've got the g function on the bottom, so I'm going to go ahead and write it that way. So the f function is x minus 1, and the g function is 8x squared minus 24x. Now there's quite a bit more going on in this particular function, especially when it comes to the denominator. So what we're going to do, we're going to set that denominator equal to 0. Then we're going to use that zero product property. Now you might notice that in 8x squared and 24x, you could take out a GCF. The GCF is 8x. All right, so you pull out that 8x and then you factor that out. You're left with an x in the first term, and then 24 divided by 8x is minus 3. Here, I know you might have forgotten about this, but this is where you can kind of split it off into two different equations. So one equation is 8x equals 0, and the other equation is x minus 3 equals 0. Now both of those equations are pretty simple to solve. Now remember, you can divide 0. You just can't divide by 0, but you can divide 0 by anything, and it's just going to be 0. So that one equals 0, and this one is going to be x equals positive 3. And like I said, we didn't just solve it. We just figured out the constraints, which is going to help us figure out the domain. So when we want to say what the domain is, again, we can fall back on that symbol, all reals. In case you're wondering, that's all reals right there. Except, and this one is our first one where we have a couple exceptions, except when x equals 0 and x equals 3. So there's a couple constraints on that. And that's, if you remember correctly, that's because our denominator had a degree of 2. You know, remember, if the degree of a polynomial is going to tell you how many possible solutions there are to that problem. Now, what I did here is I want you guys to do this on your own, and I'll just go ahead and you guys can pause the video. But this is just called putting it all together. This has kind of a little bit of everything that we've done in terms of the operations with the functions. All right, so the first one for A, you've got multiplying functions. For number 2, we have what we did today, which is division or rational functions. We have addition, and then another one with that. Go ahead and pause the video, and I want you guys to make a note of the fact that these aren't just plain f of x functions or g of x functions. Notice there's a number there's an input value in those f functions and the g functions. There's an input value that you're going to want to put in there and solve it like that. So I would highly recommend, or not just highly recommend, I would implore you to insert those values into the f function and the g value, and into those f functions and into the g functions before you start doing any of the arithmetic, really. So go ahead and pause the video at this point, and I'll just go ahead and just jot down the answers and see if your answers make sense. So for the first one, for a, I ended up getting a value of negative 88 for that function. We're multiplying the f function of 1 times the g function of negative 4, and you ended up with negative 88. Now notice how when I solved these, I solved like the f function, or evaluated, I should say, evaluated those f functions and the g functions kind of separately, and then when I was finished with that, I multiplied them out. All right, so the f function of 1 was 4. The g function of negative 4 was negative 22. So 4 times negative 22 is negative 8. For b, we have a rational function right there, which is just division. And not much really happened to this one, and I just kept it in proper form. So you got 16 thirds right there, 16 thirds. And if you wrote it as, 5 and 1/3, that's okay too. If you want to write it, I guess, as 5 and 3/10 repeating, I guess that's fine too. But repeating decimals is in essence an estimate, so it's not perfect. So it's okay. As you've learned in algebra, you know that it's okay to leave things improper. It's perfectly fine as long as you do reduce it to lowest terms. That is the most important thing. For example C here, we have the addition of the f function plus the g function of negative 2. So the f function of 4 plus the g function of negative 2, and that came out to 52. So hopefully that matches up with your answer. And for the last one, that's a rational function again, that's division, and that was 13/16. This was a pretty straightforward lesson. Hopefully you guys understood this, and that does it for, I would say, for the operations with functions, because we're going to get into kind of putting this all together to a little further extent than what we just did on this last page. But that does it for this example. So everyone have a great day. Please let me know if you guys have any questions or if you're confused on anything I covered in this lesson. All right, take care.